Hi, we're Team 5, and on this submission we are showing the F1 car moving through the curve model. And in this video we want to show and explain the physics behind of why on some situation the car follows the curve without any problem, and why in other situation the car loses grip and skids out of the track.
Our animation uses the car speed to determine the outcomes. If the car is going and now slow, it follows the curve correctly. But if the speed is too high, the car can make the turn and it slide outward, and that's skidding.
The physics behind this is basic circular motion. To turn, the car needs a centripetal force, which is equal to mass times velocity squared over the radius. Because the velocity is squared, even a small increment of this makes it much harder to turn, and it reflects in the trajectory of the particle, or in this case, a car.
The only force that can provide the centripetal force is friction between the tires and the track. So friction has a limit. When the turning force exceeds this friction limit, the car loses grips and skid. For our simulation, the maximum safe speed is 6 meters per second.
Here we run the animation. If we were to pick 6 meters per second as the velocity to run the animation, then the friction would be enough to provide the centripetal force needed to keep the car moving along the curve. If we were to pick a speed faster than that, any speed that is above 6.4, around that, because that is the maximum speed, then the friction wouldn't be enough to provide the centripetal force needed to keep the car moving along the curve, and it would skid outwards along the tangent line for a distance that we were able to calculate with the velocity, kinetic friction coefficient, and gravity.
I'm Isabella, and I'm going to explain the code that we did today for the report form. So first, we created the app design in which we made a slider. This slider has some velocities there, and the user has to choose one of the velocities in the slider. After this, the chosen velocity stores in the variable b. And now, this is the most important decision in the entire program. And the program compares if the velocity is bigger than the maximum speed that we earlier calculated. And if it's bigger, the car will skid. And if it's like equal or less than, it will not skid and it will follow the path of the curve. This is the function that we created in case the car doesn't skid. It follows every point on the curve. And like this row, we create a marker with the color red, and this draw now actualizes the value like every second, and this pause like causes like the particle doesn't stay still and it moves every 0.0001 seconds. Now with this function, we calculate the energy lost, and as the car doesn't skid, the only energy lost here is friction, and we use the work formula to get the energy lost. Then we created this function which is in case the car skids, which basically creates like the car follows its normal path, and when it reaches a critical point, it skids because basically the car like doesn't have enough friction force to make it spin, so it stops following the normal path and it follows a tangent line. Then using this formula, we calculated the total distance of the skid using the work energy theorem. Then we create this function like I mentioned before. When the car skids, it follows the tangent line. So here we basically calculate that tangent line, which is the path that the particle will follow in case it skids on the critical point. Finally, we create this function that basically calculates the amount of energy lost during the whole process of the skid.